So the title of my talk is Java Mission Control for Earthlings, and so part of Java Mission Control is actually part of SE Advanced. And SE Advanced is a suite of tools that are on top of Java SE. One of them, the main one, is Java Mission Control, but then another very prevalent one is called Advanced Management Console. And if we have time, I'll go ahead and talk about Advanced Management Console as well. My name is James Weaver. I'm a developer evangelist for Oracle Corporation. I tweet at Java FXpert, and feel free to get a hold of me anytime there. And then also, if you email me, my name is james.weaver. Some people try to contact me at jim.weaver, and that jim.weaver@oracle.com doesn't forward my email. So please don't. It's like dev/null. You know, it just won't get there. Java Mission Control actually consists of two different parts. One is the JMX console, and that's for monitoring the JVM and applications in real time. So if you want to see what's going on inside of the JVM or inside of an application in real time, you use the JMX console. Then we have the Java Flight Recorder. So that's for collecting data about the JVM and an application over time. So it's good for profiling an application. Also, Java Mission Control has some optional tools via plugins for heap dump analysis and for dtrace recording and other kinds of things that you can get with plugins. So here's an architectural view of Java Mission Control. First of all, over on the right is the user interface, and it communicates with a JMX agent. Now the JMX agent has within it an MBeam server, and the MBeam server has MBeams within them. Now those MBeams talk to instrumentation that is built into the Java Virtual Machine. There's Java Virtual Machine, the VM instrumentation, as well as application instrumentation. So architecturally, that's how it's set up. So some fun facts about Flight Recorder. There's an almost unnoticeable impact on the performance of a Java application when running in the Java Virtual Machine. The overhead is usually well below 1%. That is because there's a high-performance runtime built into the Java Virtual Machine, a high-performance recording engine that records all of the events and all of the other statistics and everything else that's going on in the JVM. There's a runtime that's recording that, and it's built in rather than having to use overhead. Now there are two startup flags that you have to pass in. They're JVM startup flags, and they have to be enabled for you to be able to do flight recordings. That's unlock commercial features, and then Flight Recorder. Now as a developer, you can use these without having a commercial license. You can use them during development. So you can use Java Mission Control and Java Flight Recorder as a developer. So we're going to go ahead and use Java Mission Control. I'm going to demonstrate it. If you download the JDK, JMC, Java Mission Control, is one of the tools that's available. So all I have to do then is type in JMC, and then Java Mission Control will come up. Now when you first come up, it will show the welcome screen, and then we just click here to start Oracle Java Mission Control. So we've got Mission Control running, and now what we need to do is go ahead and run an application that we can monitor and profile. So I'm going to go again to my terminal window, and I'm going to invoke a Java application called Load and Deadlock, and passing in those features. So I'll go ahead and run that, and it's a command line application, and when I hit enter it's going to quit, but it's just running right now. So I'll give you a little bit of an idea what it's running. It's running a Java application that's meant to cause a deadlock. So basically we have two threads that are deadlocking each other. They're both after the same resource. So when I demonstrate Java Mission Control to you, in this particular case, I'm going to be demonstrating this application. So first of all, I'll go to the JVM browser, and we notice that we have an application here called Load and Deadlock. And that's the one that we want to monitor. So I'm going to right-click on that and say Start JVM Console. And so now it's going to read those MBeams, which are reading the instrumentation, and it's going to show us a graph of what's happening in real time. So on the Overview tab, we have several things. One such thing is this dashboard that has gauges on it. In this case, by default, we have a gauge that says Used Java Heap Memory, and we have on that gauge we have two needles. One that is the high water mark for used Java heap memory, and then one is the currently used Java heap memory. And so you'll notice that as it garbage collects, it goes back and forth. The second one is JVM CPU usage. Again, we have a high water mark, the maximum that it's used in our session, and then we have another needle that shows the usage at this time. And then we have live set versus and fragmentation. So if I want to, maybe I don't want to see live set and fragmentation. Maybe I want to delete that one and then click this plus, and perhaps I want to see process or system CPU load. So I'll go ahead and click system CPU load, click finish, and so now I've got a gauge that says machine CPU usage. So there are many, as you saw, there's a very large list of gauges that you can put in that Overview tab to see at the moment what's going on very visually in a gauge. Also, here we have some graphs, and we have a processor-based graph. Here it's showing us the JVM CPU usage and machine CPU usage. And then here we have information about memory. And right now, by default, it's showing us the used Java heap memory. But perhaps I also want to see committed Java heap memory. So I would just click that, and now I'll see both lines. So I could see any number of lines on the graph that show information about memory. By the way, if you have any questions while I'm presenting, please go ahead and raise your hand and ask so that I can direct this presentation in the correct way. So another tab that we have here, down here in the Overview tab, is the MBeam Browser. So I can see lots of things that the MBeams are collecting from the JVM, lots of the values. For example, maybe in Memory Manager or Memory Pool, perhaps I want to see the PS old gen, and perhaps I want to change the usage threshold of the PS old gen. So I could double click that, and then maybe I want to change it to 256 megabytes. So I would do that, and so now I've changed it. So now the usage threshold for PS old gen is 256 megabytes. Now it's often useful to have a trigger so that something pops up when a threshold has been reached. So in this case, what I'm going to do is I'm going to configure a trigger for CPU usage. By default, it's showing maximum trigger value is 90%. I'm going to go ahead and change that to perhaps 10%. And so then, as soon as I arm that trigger, then we should see, as soon as the current value gets above 10%, we should see a pop-up that says that it's above 10%. I may have to change it to 1%. There's 10.4%. So we've got our trigger. So it's saying that that particular trigger has been satisfied. It pops us up and lets us know. So now I'll go ahead and disable that trigger so that it won't happen again during the presentation. Also, in this overview section, tab group, we have a system tab. So in that system tab, we have all sorts of server information, categories and values. So for example, the operating system, number of processors, things like that. And then we also have some JVM statistics, the number of currently loaded classes, things like that, uptime. And also we have system property values. So that's quite a long list of values. So I could filter that column. For example, if I wanted to see everything with arch in it, ARCH. So I would just go ahead and type in arch. And so now I see only the arch values. Okay. And then we have a memory tab. So the memory tab then has things about relative to garbage collection, and then also memory pools. Also up here is a heap histogram. I can click this tab or click this icon here to refresh the heap histogram, so I can see per class how many instances are there and then what their sizes are, total size that they're taking in memory. So then if I click this again, I'll get the difference between the two, the change, the delta. So now I see the delta between those two readings. And then if I'd like to force a garbage collection, I can just click the garbage icon. Okay? So then we have a threads tab. And so I can see different thread names. I can see the stack trace for the selected thread. Like for example, there's the stack trace here for that thread. And in this particular case, we're not profiling, we're monitoring this application called load and deadlock. Now remember, load and deadlock, its purpose is to deadlock two threads so that both threads are kind of in effect waiting on each other. So I'm going to go ahead and use deadlock detection here, and then I'm going to sort on the deadlocked column so that I can see the two, in this case, the two threads that are deadlocked. In addition, I'd like to see what their allocations are. In this case, they're both allocated 0 bytes because they really haven't done anything. Also, CPU profiling, so I can tell their total CPU usage. Again, they really haven't done anything, so they're 0. In addition, I'd like to add another column to the table, maybe blocked time. So I could say OK, and now it's going to tell me what the blocked time is. Or in the case that I wanted to know the lock owner name, it could give me the locked owner name. So then we have the diagnostic commands. So there are lots of different commands that we can use here. I'll use a simple one here, thread.print. So I just click thread.print and hit execute, and then it prints a stack trace of the current thread. So that's the JMX console that shows you things in real time. So now what I'd like to do, rather than monitor in real time by using the console, I'd like to go ahead and profile this application over time. To do that, I'll use Java Flight Recorder, which is part of Java Mission Control. So I'm going to right-click here. Instead of saying Start JMX Console, I'm going to say Start Flight Recording. So now it's going to say, how long do you want the recording to be? And I'm going to say 30 seconds. So I'll click Finish. And so now it is connecting with the MBeams, and it is gathering the information over time about what's going on for the next 30 seconds. And then it's recording that, all of the instrumentation that's being recorded by the JVM and our application. I could choose to run that in the background if I wanted to, but since we're going to go ahead and look at everything right now during this presentation, I didn't choose that option. So here's what's happened over the last 30 seconds. And one of the things I can do, perhaps I'm only interested in things that have happened in a certain period of time, like maybe from that to that. So we can limit the time range from the overall time range to be able to zero in on particular events that have happened. And notice here that we have a very similar set of gauges that we could add to in the console that we do in Java Flight Recorder. And so we can see things like on the Overview tab, we can see things like CPU usage and heap usage, and then some general information. And of course, some information about the Java virtual machine and other things that are applicable to this particular recording. Now, that recording gets saved in a file that has an extension JFR, Java Flight Recorder. So now we have different tab groups in this recording. Like, for example, we have memory, and this tracks things such as total machine physical memory, used memory, committed heap, things like that, and also some garbage collection, configuration, and statistics and allocation summaries, and then more information in these tabs. And then we have some information about code. So what packages are most used, and what classes in those packages are most used, and how many times, and percent. And then we have information about threads and CPU usage and thread counts, hot threads, what are the hottest threads, the most used threads, etc. We have information about I/O, so file reads and writes, socket reads and writes, things like that. And then some system information, just like we saw in the JMX console. And then we have some information about events. And so here's an overview of different events. And then we have a log of the different events. And then we can graph. We can show a graph of the events that are happening. And then we can look individually at the threads. And then we can see the stack traces, any stack traces that have occurred. And then a histogram. What I'd like to do now is show you the process of using a profile to diagnose a problem. So earlier I took a flight recording of an application called Hot Methods, in which the performance of the application was pretty slow, and also the CPU I noticed was saturated. When I looked at the profiling, or looked at the console, I noticed that the CPU was saturated. It was being fully loaded. And so I took a profile of that, I took a flight recording of that, and wanted to see what was going on. So I'm going to go ahead and load that flight recording. So I'm going to go ahead and close this one out. And I'm going to open that flight recording. And I named it Hot Methods. Actually, a colleague did this and named it Hot Methods. So this is the flight recording, and notice in the General tab that the CPU usage is maxed out. It's saturated. And so if I go, so I want to find out why. Why is the CPU maxed out? So I'm going to go to code to find out what the hot packages are. Well, java.util is the hot package. It's the one that's most used. It's using 94%. And then, so what class in that package is being used the most? Well, linked list is. It's at 97%. So I want to dig further now. What method in that linked list class is being used the most that is consuming the CPU? So here we see this index of method of linked list, which is being called by the contains method of linked list, which is being called by one of the methods in our application called counter intersection, or count intersection, which is being called by the worker class, which is a class that's in our application. Now here is the application so that you've seen it here, or at least one of the classes in the application. It's called initiator, and we're basically opening a collection, creating a collection, a linked list, and then we're trying to find out what the intersection of two linked lists are. And so we're doing a method called contains, which is a method of a container class, a collection class. So with a linked list, when you do contains, it does an index of, and with a linked list, it's proportional. The time is proportional that it takes to find a particular element in a linked list. And so if it's toward the end of the list, you're going to consume a lot of CPU time. And so that's exactly what's happening. So we'll look here at this at the hot methods, and we can see that the contains and finally the index of is taking all the time. And if we could see that another way, kind of backwards, we could look down and see thread.run, calling worker.run, calling initiator, counter intersect, count intersection, calling contains, and calling index of. So just two ways. One's a call tree and one's the other way. So then if we wanted to find out, so now we've identified what the problem is. The problem is that. So the solution in this particular case was that we used a hash set instead of a linked list, and because that has a consistent amount of time for accessing a particular element in that particular collection, and then that solved the CPU saturation problem. Okay? So then the next scenario that I'd like to talk about is diagnosing by profiling when you suspect a latency problem. So in this case, I've got an application, and the relevant class in that application, the relevant code, is one called logger. And in this particular case, we have this method that we've used the keyword synchronized on, and we call it log, and then it's going to log some information. So but it's slow. We notice that it's very slow, but when we look at the CPU usage, we notice that it's not maxed out. Let me see if I can make that bigger. So the aspect ratio on this screen is not allowing me to make this bigger. But this graph is maybe around 30% or 20%, not 100%. So it's not maxing out the graph or the CPU. So we need to look further to find out why the application is slow. So since we suspect latency, I'm going to go ahead and click on threads and try to find out what's going on with it. and again, we can see the CPU usage, and we can see there's some hot threads, but really don't find much there. Let's look at events, and over time, then we can see that there are some events, but we notice something very peculiar. That if we look at a graph of the events, or sorry, one second. So we look at we were back at threads, sorry, and we can see our threads. Since we suspect that there is maybe a latency problem, I'm going to go ahead and click on the Latency tab, and we notice something very odd, and that is on this particular thread. The thread has been waiting, or the Java monitor has been blocked for 15 minutes, but it was only a 1 minute sample. The interval was just 1 minute. So why would we wait 15 minutes on a 1 minute? Well, there are several threads, and each of those threads has been blocked. So if I looked at locked instances, and I look at this particular monitor, I notice that there are several threads that are waiting on that monitor, and this stock trace is very shallow because it's a test application, but this worker thread run is calling log, and all of those threads that are calling log are waiting on the same monitor. So that's where our latency problem is. So it turns out to solve that particular problem, we simply remove the keyword synchronize, because that wasn't really necessary, because the underlying logging mechanism will synchronize for us. So that wasn't necessary, but that's how you would diagnose a latency problem. So any questions so far on Java mission control before we turn to another subject? Yes? Okay, so the recording actually, you're right. It happens in the JVM, or in that facility, and so I suppose by going through the MBeams, you could use some other client to activate the recording. But yes. Oh, that's a very good question. The question is, can we record for hours and days? And I do not know the answer to that question, but if you email me, I will find the answer to that question. I will connect you with the lead engineer of the Java Mission Control, and we can and I will get you that answer. Yes. Other questions? Okay. Alrighty. So yes, I'm sorry. I'm ignoring you over there. I'm so sorry. Yes.
The UI looks a lot like Eclipse. Is this a coincidence, or is there a plugin to have a perspective?
Yeah. So the question is, or the observation is that this looks a lot like Eclipse, and in fact, you can run Java Mission Control as an Eclipse plugin. Go figure. Okay. Very good question. Yes. It's not written in JavaFX, but the next application I am going to show you is written in JavaFX. Yes. Other questions? Good. Thank you for your questions. So the next topic of conversation then is the Advanced Management Console. So that's written in JavaFX, and what that's is it's built for being able to manage the Java clients in your enterprise. So you may have Java applets or Java Web Start applications that each take different versions of the Java virtual machine, and you may want to impose different restrictions on different applications and applets in your enterprise. So this way you can create deployment rules, and also it comes with a tool called the usage tracker that allows you to even find out what Java applets and applications that you have in your enterprise. And then those are collected by the tracker and then recorded on the server. They're stored on the server, and then with the Advanced Management Console, we can then find out what the tracker, the usage tracker, has found, and then we can also create deployment rules so that we can manage the capabilities. So first of all, we have these things called deployment rule sets. So we have many managed clients, and then, as I said, different applications need different Java versions. And then different users might need several different applications at the same time. So we have this concept of rules and groups. And then sometimes we need to whitelist or blacklist particular applications. So we want to say, you know, they can run or they can't run. And so we want to be able to, because one application might need one version of Java, maybe one needs 6 update 38, this one needs Java 8. That's one of the things that the Advanced Management Console manages. And also, again, we need to be able to block the usage or use or whitelist applications. So we'll go ahead and run Advanced Management Console. And we have the Home tab here. And those are just links to all of the functionality within. Those are kind of quick links. So we can look at apps. And apps, these apps are, can you see that, by the way? I hope you can. Okay. So the apps are the ones that are collected by the Java usage tracker. So in this case, I went ahead and used a Big Bang Theory kind of motif here. And here we've got a theoretical physics scratchpad application, or a method acting tutorial application for Penny, or an astronaut nicknamer for, let's see, who's the guy that the astronaut, Wallowitz, yeah, that's it, and then a Comic-Con application. So, and then we have the title, the URLs, the vendors, and then the descriptions. And so if we wanted to know more information about the theoretical physics scratchpad, then we could just click that and say inspect, and we could see who the vendor was, the description, and also the list of jars that make up the app, and any optional JNLP extensions, and then also the JRE version and run count. So in this case, we've got the run count. It's been run 8 times, but it's been run only by one unique device. So we can see how many times an application's been run, or an applet has been run, and also by how many unique devices. So then we have rules. So we could go to the Rules tab, and we can see that we have some rule sets. Here we've got a Science Department rule set. So in the Science Department, we might want to allow them to use the physics scratchpad and the astronaut nicknamer and things like that. I'm going to go ahead and delete that rule set because we're going to build that in a second. So, so these rules in this rule set are chosen from all the applications. So we can see then the effect. If I go to Science Department and I show the rule set relationships, I can see that the physics scratchpad is going to be allowed to run, but this down arrow, because if I look at, for example, the physics scratchpad and inspect that, it shows that the user is going to be given shown the default dialog boxes in order to be able to run that. And if I, for for example, show the astronaut nicknamer, it shows that the user is going to be able to run it, but it's going to force it to use Java 8, API level 1.8 or later. And so then in this rule set, when I show the relationships, then it's going to show those rules and the effect upon the applications. So this one can run. That one is going to have the user show the default dialogues. This one is going to be blocked, and this one is going to be run, but forced to run at a certain level of the JVM version of Java. And so now, if we wanted to add a rule set, then we could go over here and click Add Rule Set. So maybe we want to have a rule set for somebody's home office. So we'll say Home Office Rule Set. And then we could go ahead and drag different applications into that. And so then somebody in the home office rule set would be able to use Physics Scratchpad, Astronaut Nicknamer, and let's say Comic-Con. And also, if we wanted to add create a rule, then we could create a rule here. And also, if we wanted to create an application and with a new rule, we could just say new rule here based upon that particular application. The rules for that particular application here in that case is the default, which makes the user click default dialog buttons, and then we could add the rule. So any questions on the Java Advanced Management Console? Okay. Okay, any questions on anything in general? Anything about, or anything you'd like to see more of in the JMC? Maybe any scenario you'd like me to demo in the Java Mission Control? Okay, yes?
So, Advanced Management Console is run on the server JVM, and the rules apply to the server. It's just constantly running, basically. And then the JNLPs, they each have a location. So how does that work exactly? So, I mean, someone connects using to that location, and then when the server wants to serve, they check these rules.
Right, right. So the question is, stating that the Advanced Management Console actually runs on a client because it's a JavaFX application running on a client, but then you have the usage tracker that runs on a server, and then as these applets and applications are invoked, they're reporting the information to the usage tracker, and that information is held on a server. What's happening is when you use this tool, the Advanced Management Console, it creates then a deployment rule set, which is an XML. It's expressed in XML, and then that is used by a server process to be able to allow or disallow an application to run.
And the server already knows about how does the server know about
the deployment rule set, it knows via the deployment rule set, and so there's a process there that knows about that it read the deployment rule set in, and then it manages that. So to get any more detail, if you'll email me, I'll connect you with Joe McGlynn, the engineer that's responsible for Java Advanced Management Console, and he'll give you all the gory details. So, other questions? Well, you've got 12 minutes of your day that I'm going to give back to you, and thank you very much.